This video is about finding the domain of a function. So we're going to look at three different functions. The first one is f of x is equal to 4x divided by x squared minus x minus 6. So the thing about domain is the domain of a function is every real number x you can allow into the function as long as you don't divide by 0 or allow a negative under a square root, which would put us in imaginary numbers. Or if you had a logarithm function, you can only put in positive numbers into a logarithm. There's no logarithms in these examples, so we won't be worrying about that right now. The first one, you ask yourself, what are the issues? Does it have any issues? And so whenever you have a division problem, and any fraction is a division problem, you gotta ask yourself, is it possible that the denominator could equal to 0? Because if so, then you would be trying to divide by 0, and that's not allowed. The other thing you ask yourself typically is, do I see a square root symbol? Meaning like this square root symbol right here, or this square root symbol. And I do not, so I don't have to worry about that. So the only thing for function number 1 is division by 0 that I have to worry about. So you ask yourself, when will the denominator be 0? So this is how you figure that out. You set the denominator, whatever it happens to be, equal to 0 and see if it's possible to make it be 0. And it is. We could solve this equation for x. I'm just going to factor this x minus 3 times x plus 2. Let me double check. This is x squared minus x minus 6. This is what it factors into. This will be true when x is 3 or when x is negative 2. That means that when x is 3, the denominator will equal 0. Or when x is negative 2, the denominator will equal 0. That means we'd be trying to divide by 0. So since we're trying to find domain, that means I cannot let those numbers into this function. Those have to be restricted from the domain. So if I have to write the domain in interval notation, this is a real easy way to think about it. You can mark the numbers that are not allowed in on your number line, and I draw open circles over there. And then you write down all the other numbers. And so the only way to write an infinite amount of numbers easily is with using interval notation. So way out here is the number negative infinity, and way over here is the number positive infinity. So I'm just going to start writing down all the numbers. We're going to go from x is negative infinity all the way to just to the left of negative 2, and we indicate that with a parentheses. And so then all these numbers in between are also good, so we want to talk about those. For instance, it's okay for x to equal to 0 or negative 1 or 2 or any of the numbers in between there. So we want to include those in the domain. So this indicates pick up just to the right of negative 2 and go all the way to the left of negative 3. And then we hop over 3 and we say all the numbers to the right of 3 to infinity. Okay, that's the first one. That's the domain of the first function. So g of x, so I'll call that domain of f is this. Okay, domain of g. Let's look at the g function. I do not see a division problem going on. I don't see a fraction. There's no dividing going on, so I don't worry about division by 0. But what I do see is a square root. When you have a square root, you have to make sure that you do not enter the dimension of imaginary numbers. So the square root of negative 1 is I, the imaginary number. So what that means is, as long as I don't have negatives under my square root, I won't be in that problem. I won't be in the imaginary number. So what you do is you take whatever happens to be under the square root. So in this case it is 2x plus 7, and you must tell this quantity. You say, hey, you're not allowed to be negative. You can be positive, which means greater than 0, and you can even equal 0. That would be okay. So you set up this inequality and solve for x, and that basically tells you all the x's that are allowed into this function. Notice that I didn't worry about the 3, I didn't worry about the negative 5, because those were not under the square root symbol, so those are not a problem for me. So I solve for x. 2x is greater than or equal to negative 7. I divide both sides by 2, and I get x has to be greater than or equal to negative 7 over 2. So as long as x is greater than negative 7 over 2, I'm not going to be putting negative numbers in here, and I will be in an okay domain. Again, you can graph this. So here's 0, maybe here's negative 7 over 2. This says all the x's that are to the right of or equal to negative 7 over 2. So that means from here to here. That is my domain. How I write that in interval notation means I can include -7/2, and I can go all the way to infinity. That's the domain of G. All right, let's look at H. In H, we have two things going on. We have division problem, because I see a fraction, and we also have a square root. So we got to handle both of those issues. We can't divide by 0. Okay, so here's one thing. The square root of 6x minus 2 cannot equal to 0, and also they can't have negatives under here. So first, let's deal with the imaginary number issue. First, let's say 6x minus 2 has to be greater than or equal to 0. That way we won't get kicked into imaginary numbers. So let's solve this inequality. 6x is greater than or equal to 2. X is greater than or equal to 2/6 or 1/3. So this is the domain, except the problem is this is in the denominator. So how we take care of this is we can't let this go negative, but we also can't let it equal to 0. If we remove this or equal to sign here, in other words, we solve this inequality, 6x minus 2, as long as it's greater than 0, then this square root would not be equal to 0, and we won't be dividing by 0. This saves us from both situations. So that would be 6x is greater than 2, x is greater than 1/3. Then we are not dividing by 0 or getting kicked into the imaginary number world. And so the domain of H is going to be from 1/3 to infinity. Notice I don't put a bracket on the 1/3 because that would mean it could equal 1/3, and it's not allowed to this time. So that is domain. One other thing I want to point out is that when I was looking at number 1, division by 0, notice that the numerator, I did not care what the numerator was. I didn't even look at the numerator, 4 times x, because I don't divide with the numerator, so it doesn't hurt me when it comes to domain. So I only considered the denominator right there.